All right, section 4.3 is some fundamental polynomial operations. So first, let's look at what polynomials are. Polynomials are expressions that look like this, okay? So one thing I want you to notice, all the exponents are going to be positive, and all the exponents are going to be whole numbers, okay? So I won't have any fractions in my exponents, and they won't have any negative numbers in my exponents. They're all going to be nice, pretty numbers like, again, remember, even though I don't see it, there's a 1, a 2, a 3. That's what my exponent is going to look like. The numbers in front, they could be fractions, they could be decimals, but the exponents are going to be nice, pretty whole numbers, okay? A multivariable polynomial is when we have more than one letter, right? So if you notice here, we have a 5xy, we have a 7xy, we have an x to the third, y to the ninth. That's what we call multivariable, okay, because there's more than one letter. So now we have something called the degree of a term, and it says the degree of the term is the sum of all the exponents. Guys, so one thing is sum just means to add. So it says, for example, the degree of 7x to the third is 3. Why? Because that's the only exponent we have. The degree of 4xy is 2. Why? Because the exponents on both of those are 1, and if we add them together, we get 2. Same thing here. If we add those exponents together, we get 6. Now I know they're not the same variable. They're two different letters, but that's just referring to the degree. Okay. Then we have something called the degree of the polynomial. The degree of the polynomial is going to be the highest degree of all the terms. Okay, so here it says, for example, the degree of this one here is 3 because that's the highest exponent. And the degree of this one here is going to be, let's see, 4. Those are each 1, so the degree of that term would be 2. That's a 1, so the degree of that term would be a 3. That's a 1, so the degree of that one is a 4. So since that's the highest one, that's one we're going to pick. Okay, so the directions here say state the degree of the polynomial and whether it's a monomial, binomial, or trinomial. I'm going to explain that part to y'all right now. So number 1, let's find the degree. Okay, the degree, we're just going to add the exponents together, 5. Okay, guys, monomial means that there's one term. Binomial means there's 2. Trinomial means that there's 3 terms. There's only one piece here, so this is a monomial. Okay. The degree of the next one. Okay, what's the highest exponent here? Well, the degree is 3. And if I notice, I have 1, 2, 3 pieces, so this is going to be, a trinomial. Okay. Let's do the next one here. The degree, let's see, that's a 1, so the degree of that piece is 5. 5 and 2 is, okay, so the degree is going to be 7. And if you notice, I have 1, 2 pieces. This is what we call a binomial, okay? All right. Adding polynomials. Guys, adding polynomials simply is just combining like terms. We've combined like terms before. So negative 2x plus 5x, if I combine those together, that's going to leave me with a 3x. A plus 19 and a minus 6 will leave me with a plus 13. Okay. Let me go to the next one. So again, I'm going to add my like terms. Okay. So guys, if it helps, that's a 1x squared and that's a negative 1x squared. Those are going to cancel. Okay. A negative 4x and a negative 1x. So if I owed you 4 and I borrowed 1 more, now I owe you 5. If I owe you 8 and I pay you 1, now I owe you 7. Okay. Let's see. For the next one, I'm going to grab my calculator right here. Let me clear that out. Okay. So let's see. We have 4.6, and that's negative, plus 9.8 is 5.2. Oh, oops, sorry, my mistake. I can't combine those two together. I just realized that. One of them is an x to the third, and one's an x squared. So they're not like terms. Okay, so negative 4.6x to the third plus 9.8x squared. I can't combine those. These we can combine because they're both x's. So let me grab my calculator again. Alrighty. So 5.6 plus 4.5 is 10.1. That's the number in front of my x, 10.1x. And then we have a negative 0.3 and a minus 1.7. So let's see, clear that out. 0.3 negative minus 0.7 equals negative 2. So negative 2. Okay? And there's my answer. Okay. Now, for the next couple of problems, guys, when we are subtracting, it's going to be very similar to adding polynomials. The only thing we're going to do slightly different, I'm going to think of the number right here as a negative 1. So my first part, I'm going to leave it alone, 5x minus 5. I'm going to distribute that negative 1 to both pieces. Negative 1 times 6x will be a negative 6x. Negative 1 times negative 3 will give me a positive 3. Now, when we combine like terms, 5 minus 6 is a negative 1x. You can write negative x if you like. Minus 5 plus 3 is a minus 2. You can write it like that, guys, or you can write it like this. Okay. All right, let's do the same thing for the next one. I'm going to think of this number here as a negative 1. My first part, guys, stays exactly the same. So 2x to the third, I'm going to just write that as a minus 1x squared and a plus 5. And I'm going to distribute. So negative 1 times 6 is a negative 6x to the third. Negative 1 times x squared is a negative 1x squared. Negative 1 times another negative 1x is a positive 1x. And negative 1 times positive 1 is a negative 1. Okay. Now let's go ahead and combine our like terms. So minus 2, minus 6, negative 4, x to the third. A minus 1x squared and another minus 1x squared is a minus 2x squared. Okay. This is the only x that I have, so I'm just going to write it as a plus x. And then we have a plus 5 and a minus 1 to leave us with a plus 4. Okay. Guys, I'll do the same thing here for the next one. I'm going to think of the number right here as a negative 1. So I have 1.3 x to the fourth minus 3.1 x to the third plus 6.3 with an x, okay, minus 1 x to the fourth. Negative and negative is positive, 5.2 x squared minus 6.5 with an x. Okay. So let's go ahead and combine our like terms. 1.3 minus 1 would just give me a 0.3 x to the fourth. Okay. There's only 1 x to the third, and it's at negative 3.1 x to the third. Okay. Plus 5.2 x squared. Okay. Let me see if I can move to my right a little bit, because I'm kind of running out of room. Oops. Kind of running out of room here. Let's see. All right. And let's see. 6.3 minus 6.5 would give me a negative 0.2x. And there is my answer. All right. Let's take a look at these next two. So it says perform the operations indicated. Okay, so what I'm going to do here, because those are being added, those we can do relatively quickly. 8x plus another one is a 9x. A plus 2 and a minus 7 is a minus 5. Now, I will think of this here as a negative 1. That's a negative 3x and a minus 1. So 9 minus 3, 6x. A minus 5 and a minus 1 is a minus 6. Okay. And we'll do the same thing for the next problem here. We are combining like terms, so we have to make sure they're exactly the same. So look, this one here and those are exactly the same. They're both x squared y's. So 12 minus 2 is 10, x squared y. Look, this is a negative 1 xy squared, so this one and those are the same because they're both xy squared. So negative 1 plus 5 is a plus 4 xy squared, and a plus 5 and a minus 8 is simply a minus 3. Okay. All right, let's take a look here and see if we can figure out the next one. Again, I'm going to go ahead and put my negative 1 right there, so I'm going to leave this piece alone. 3b to the third minus 5b squared minus 7b. And if I move or multiply my negative 1 to negative 2b to the third, a negative 3b and a positive 5. Okay. So let's see. 3 minus 2 is just a b to the third. Let's see, this is the only b squared we have, so minus 5b squared. Minus 7 and minus 3 is a minus 10 with a b. And then finally, a plus 5. Okay. All right. Let's see, the next problem here, the last problem actually says, the number of prisoners held in federal and state prisons measured in thousands can be described by the polynomial. It gives me this expression here. The variable x represents the number of years since 1990. And the directions are telling me estimate the number of prisoners in 2005. Okay, what's important here is, number one, to read the problem, but to make sure we understand what the letter x is. The letter x is the number of years since 1990. Okay? If we're trying to figure out the number of prisoners in 2005, what we're going to do is we're going to find what x is for 2005, okay? We're going to take 2005 and we're going to subtract 1990. We know how many years it's been in between there. And so again, guys, if I were just to grab my calculator right here and to say, what's 2005 minus 1990, we end up with 15, okay? So this is telling me that x is equal to 15. And what we're going to do is we're going to come back to this expression right here. And everywhere we have the letter x, we're going to plug in the number 15. So we're going to go slow here. So negative 2.06, 15 squared, plus 77.82 times 15, plus 743. Okay. So the first thing I got to figure out is what's 15 squared. So 15 times another 15 is 225. So I'm just going to write this out like this. And I'm going to keep the rest of it the same for right now. And the next part, guys, I'm just going to use my calculator. Okay, so look, let's take 15 times negative 2.06 times 2.06 negative equals negative 463.5. Negative 463.5. Okay, plus the next part, we're going to have the number 15 times 77.82. 1167.3. 1167.3 plus 743. Okay. So guys, on my calculator, I'm going to add these two numbers together, and then I'm going to subtract that one because it's negative. So let's add 743 and then subtract 463.5 equals, and I am coming up with 1446.8. 1446.8, okay? And so let me make sure I'm answering the question. So it says the number of prisoners measured in thousands, okay? So this is in thousands, right? In thousands, right? If we wanted to figure out the number, guys, we can multiply this number by 1,000. And that would give me that number right there. For your homework, you're going to enter in this number, though, because it would be in thousands. But if you wanted to know what does that number really look like, so we have 1446,800. So 1446,800, right? So that number would really be 1,446,800. If that's what we wanted to look at, but this is the number we would enter in, okay? And that is 4.3.